Here, we're going to start applying the laws of exponents in the following example. So in our first example, we have m to the 7th power times m to the 3rd power. So what it means is that since they're the same bases, I'm going to write my base once, and simply I'm going to add my exponents, 7 plus 3, so my final answer would be m to the 10th power. So this is my final answer. So same thing over here. It's the same base, h to the 5th power times h to the 9th power. I'm going to write my h once. I'm going to add my exponents, 5 plus 9. So it's going to be h, 5 plus 9, that's 14. So h to the 14th power. So that's all you have to do. Now, some cases, you might have multiple variables. So let's do an example. So say you have x to the 3rd power, y to the 5th power, times y to the 6th power, times z to the 2nd power. So from here, the only exponent you're going to mess with is the one that has same base. So this one right here, my y. So what I'm going to do is, I'm simply going to combine my y's. That's it. The x will stay the same, the z will stay the same. So putting it in alphabetical order, x to the 3rd power, my y, since there's same base of y's, but my exponents are different, so 5 and 6. So again, it's multiplying. I'm going to add the exponent. So 5 plus 6, and then z will stay the same, so z to the 2nd power. So the only thing I'm adding is that 5 and 6. So my x to the 3rd stays the same. Now my y will be to the 11th power, and then z. So again, my x stays the same, my z stays the same. The only thing was I combined the exponent for y because it was multiplying. So this m to the 10th power is my final answer. H to the 14th power is my final answer. And this term, x to the 3rd times y to the 11th times z to the 2nd, is your final answer. So you only add the exponents when there's two bases. Let me clarify. When two same bases are multiplying, you add this exponents together. Alright. So now we're working with the second law of exponents, where we're going to be dividing, therefore we're going to be subtracting the exponents. In this example, so it's the same base and it's dividing. So I'm going to write the base once, which is n, and it's usually the top exponent minus the bottom exponents. So 10 minus 4. That means that my final answer would be n to the 6th power. That would be our final answer. There's nothing else you can do. Now, same process. Same bases are dividing. So s to the 24th power divided by s to the 15th power. That means it's going to be s 24, since that's my top exponent, minus the bottom, which is 15. So s 24 minus 15, that's going to be 9. So s to the 9th power. And that's my final answer. So now we have another example similar to what we did previously with multiple variables. And the same thing can be applied if you have multiple numbers. So the only ones I'm messing with is the ones that has the same base, which is my b's. So my a to the 7th power will stay the same. And then it's going to be b, where it's going to be my top exponent minus my bottom exponent. So 8 minus 5. So it's going to simplify into a to the 7th power, and then b, 8 minus 5 would be to the 3rd power. So that will be our final answer. And then that's all we have to do. Alright, now we have some examples working when you have an exponent inside the parenthesis and an exponent outside the parenthesis. So when you have an example like x to the 4th powered by 7, so it means that it's x, where it's going to be 4 times 7 for the exponent. When that happens, it's going to be x to the 28th power. So to review, simply just multiply the exponents. Only when you have an exponent inside the parenthesis and outside the parenthesis. So same process. So m to the 8th power being raised by the 5th power, so it's going to be m. 8 times 5 for our exponent, so it's going to be m to the power of 40. So that's all we have to do for this example. Now in the last example, it's a little bit more complex. So it doesn't matter which method you use. Now my students, they usually write arrows to help remember that they're distributing or multiplying the exponents, which is fine. You can do that as long as you remember that you're multiplying the exponent. Sometimes students, they confuse that they were adding versus multiplying. So here, when you have exponents on the inside of the parenthesis and an exponent on the outside, you're just going to multiply only, and I repeat, only to the exponents. Only to the exponents. So it will be my a, 4 times 9, my b, 6 times 9, my c, 7 times 9. So I'm going to simplify all the exponents. So for the a, 4 times 9 would be 36. My b, 6 times 9 will be 54. And then my c, 7 times 9 will be 63. So again, I didn't mess with the a, I didn't mess with the b, and I did not mess with the c. So I only multiplied to the exponent only. And that's my final answer. In this example, it's very similar to the last one that we just did. Now the only difference is that you don't see an exponent on the y. When you see a variable or a number, this also applies to numbers. When you see a variable or a number by itself, they actually have an invisible exponent. That invisible exponent is 1. So again, take note, when you have a variable by itself, so like say a, and say like 5, when you see them by themselves, they actually have an exponent, which is the invisible 1. So a to the 1 power is simply just a. 5 to the 1 power is just 5. So when your base is like a, and when your base is like 5, or by itself, it's just having an invisible exponent, always. So like here, the y looked like it was by itself, but it has the invisible exponent. Now, again, I mentioned how my students would like to draw arrows so that it makes them remember that they're just multiplying. So on my x, it's going to be 3 times 5. My y, 1 times 5. And then my z, 8 times 5. So the x, when I simplify, 3 times 5 will be 15. And then my y, when I simplify, is going to be 1 times 5, which is 5. And then my z, when I simplify, is going to be 8 times 5, which is 40. So there is our final answer. x to the 15th power times y to the 5th power times z to the 40th power. And then there's our final answer. As we progress, we're going to start working with numbers, and the law of exponents will apply same as how it applies to the variables, same process, same law of exponents when the bases are numbers. In this examples, we are going to be working with negative exponents. So again, as I stated with the laws of exponents, in order to convert them into positive exponents, because in your final answer you have to have positive exponents, simply move it to the other side, meaning move the base and the exponent to the other side. So let's take a look at the first example we have here. M to the 4th times n to the negative 7th over p to the 11th power. So the ones with the positive exponent will stay where they are, so m to the 4th on the top, and then p to the 11th will stay on the bottom. Now my n is the one that's going to move to the opposite side, so from top to bottom, so n. Now I put it in the front because I want to put in alphabetical order. When I move from top to bottom, my exponent will change into positive, so positive 7. And then there is my final answer. Alright, now in the next example, we actually have a base with a negative exponent in the numerator and in the denominator, my c with a negative 5 and my g with a negative 8. So all we're doing is simply leaving the ones with a positive exponent where they are. So I'm going to have d to the 6th power stays at the top, and then my h stays at the bottom. The only one that's switching places is my c and my g. My c will go from the top to the bottom, so c with a positive 5 as exponent, and then my g going from the bottom to the top with a positive 8 as the exponent. That's all I did. Switch places in order to convert negative exponent into positive exponent. So this is my final answer. And that's all you have to do.